According to the National Electrical Code, for oil-filled transformers of any voltage, the minimum dielectric strength of the oil shall be 26 kilovolts. Therefore, based on the NEC, the oil in the transformer has failed and should be replaced. The dielectric strength test is typically performed using a standard test cell that is filled with the transformer oil. The test voltage is applied gradually until the oil breaks down and an electrical arc is formed. The voltage at which the breakdown occurs is the dielectric strength. Different test methods and instruments can yield slightly different results. However, the NEC specifies the minimum acceptable dielectric strength regardless of the test method used. When assessing transformer oil dielectric strength, several factors should be considered, beginning with the applicable standards. The NEC serves as a baseline, and exceeding the minimum requirement offers an additional margin of safety and reliability. Consider the age of the transformer. Over time, transformer oil degrades due to thermal stress, oxidation, and contamination. Regular oil testing is essential to monitor its condition and ensure it meets the required dielectric strength. The type of transformer also matters. Different types of transformers, such as power transformers or distribution transformers, may have specific oil requirements based on their application and operating conditions. Ambient temperature can impact dielectric strength. Higher temperatures can reduce the dielectric strength of the oil. It is essential to ensure that the transformer operates within its design temperature range. Moisture content significantly affects dielectric strength. Even small amounts of moisture can drastically reduce the oil's ability to withstand electrical stress. The oil should be regularly tested for moisture content and dried or replaced if necessary. Particulate contamination in the oil, such as dirt, dust, or metallic particles, can also lower dielectric strength. Oil filtration or purification may be needed to remove these contaminants. The testing method itself needs standardization. Ensure that the testing method used is in accordance with recognized standards such as American Society for Testing and Materials Date 177 or International Electrotechnical Commission 60156. The accuracy and calibration of the testing equipment are crucial. Use calibrated equipment and follow the manufacturer's instructions carefully. Variations in testing procedures can lead to inconsistent results. Maintain consistent testing procedures and environmental conditions to ensure reliable and comparable results. The interpretation of the test results is important. Understand the significance of the dielectric strength value and compare it to the NEC minimum requirement and the manufacturer's recommendations. If the dielectric strength is below the minimum acceptable level, take appropriate action, such as oil replacement or reconditioning. Oil reconditioning involves removing contaminants, moisture, and oxidation byproducts to restore its dielectric strength. However, reconditioning may not always be sufficient, and oil replacement may be necessary if the oil is severely degraded. In addition to dielectric strength, other oil quality parameters are important, such as acidity, interfacial tension, and color. Monitor these parameters to assess the overall condition of the oil. Regular transformer maintenance, including oil testing, helps prevent failures and extends the life of the transformer. Implement a preventive maintenance program to identify and address potential problems before they become critical. When handling transformer oil, follow safety precautions to avoid spills, contact with skin, and environmental contamination. Dispose of used oil properly in accordance with environmental regulations. Consider the environmental impact of transformer oil. Use environmentally friendly oil alternatives such as ester fluids, if appropriate. Ester fluids have higher biodegradability and lower toxicity compared to mineral oil. If the transformer is critical to operations, consider having a backup transformer or a spare oil supply available to minimize downtime in case of oil failure. Proper transformer design and installation can also help extend oil life. Ensure that the transformer is adequately ventilated and protected from environmental factors that can accelerate oil degradation. Monitor the transformer's operating parameters such as load, voltage, and temperature to identify any abnormal conditions that could stress the oil. Consider using online monitoring systems to continuously track oil condition and transformer performance. These systems can provide early warnings of potential problems and allow for proactive maintenance. If you are unsure about the test results or the appropriate course of action, consult with a qualified electrical engineer or transformer specialist. They can provide expert advice and guidance based on your specific circumstances. Remember that the NEC is a minimum safety standard. It is always a good practice to exceed the minimum requirements whenever possible to enhance safety and reliability. Stay up to date with the latest revisions of the NEC and other relevant standards to ensure that you are following the most current guidelines. Proper transformer oil management is essential for ensuring the safe and reliable operation of electrical systems. By understanding the NEC requirements and implementing best practices, you can minimize the risk of transformer failures and extend the life of your equipment. In summary, firstly, know the NEC minimum dielectric strength requirement of 26 kV for transformer oil. Secondly, consider the age, type, and operating conditions of the transformer. Thirdly, regularly test the oil for dielectric strength, moisture content, and contamination. Fourthly, maintain consistent testing procedures and use calibrated equipment. Fifthly, interpret the test results carefully and take appropriate action. Sixthly, consider oil reconditioning or replacement if necessary. Seventhly, monitor other oil quality parameters. Eighthly, implement a preventive maintenance program. Ninthly, follow safety precautions when handling transformer oil. And tenthly, consult with a qualified professional if needed. Remember that dielectric strength is a critical indicator of the oil's ability to insulate and prevent electrical breakdown. Maintaining adequate dielectric strength is essential for ensuring the safe and reliable operation of the transformer. The NEC requirement is designed to provide a minimum level of protection against insulation failure, which can lead to equipment damage, power outages, and safety hazards. Transformer oil serves multiple functions, including insulation, cooling, and arc quenching. Its dielectric strength is a measure of its ability to withstand electrical stress without breaking down and forming a conductive path. When the dielectric strength of the oil falls below the minimum acceptable level, it increases the risk of insulation failure and flashover. This can result in short circuits, equipment damage, and potential safety hazards. Therefore, it is crucial to monitor the dielectric strength of the oil and take corrective action if it is below the required level. The NEC requirement of 26 kV is based on years of experience and research in the field of transformer insulation. It represents a balance between safety, reliability, and cost-effectiveness. While exceeding the minimum requirement is always desirable, it is important to ensure that the oil meets at least the minimum standard specified in the NEC. When testing transformer oil, it is essential to follow the proper procedures and use calibrated equipment. The test should be performed by qualified personnel who are familiar with the testing methods and the interpretation of the results. The testing environment should be clean and free of contaminants. The oil sample should be representative of the oil in the transformer. The testing equipment should be calibrated regularly to ensure accuracy. The test results should be documented and compared to previous results to track changes in oil condition over time. If the test results indicate that the dielectric strength of the oil is below the minimum acceptable level, further investigation is warranted. The cause of the low dielectric strength should be identified and addressed. Common causes of low dielectric strength include moisture contamination, particulate contamination, oxidation, and thermal degradation. Depending on the cause of the problem, the oil may need to be dried, filtered, reconditioned, or replaced. In some cases, the transformer itself may need to be inspected and repaired. The decision of whether to recondition or replace the oil depends on several factors, including the severity of the degradation, the age of the oil, the cost of reconditioning versus replacement, and the importance of the transformer to the overall system. Reconditioning can be a cost-effective option for restoring the dielectric strength of the oil, but it may not be sufficient if the oil is severely degraded. In such cases, replacement may be the only option. When replacing transformer oil, it is important to use a high-quality oil that meets the manufacturer's specifications and the requirements of the NEC. The oil should be compatible with the transformer materials and designed for the specific operating conditions. The oil should be filtered and tested before being placed into service. The replacement process should be performed by qualified personnel who are familiar with the proper procedures. After the oil has been replaced, it should be tested again to verify that the dielectric strength meets the minimum acceptable level. Regular transformer maintenance, including oil testing and analysis, is essential for ensuring the long-term reliability of the transformer. A well-maintained transformer will operate more efficiently, last longer, and reduce the risk of failures and outages. A comprehensive maintenance program should include visual inspections, electrical testing, oil testing, and mechanical inspections. The frequency of maintenance should be based on the age, condition, and operating conditions of the transformer. Transformer oil is a valuable resource, and it should be managed responsibly. Used transformer oil should be disposed of properly in accordance with environmental regulations. In many cases, used oil can be recycled or re-refined for use in other applications. By following these guidelines, you can ensure that your transformer oil meets the requirements of the NEC and contributes to the safe and reliable operation of your electrical system. Remember that transformer oil is a critical component of the transformer, and its condition directly affects the performance and reliability of the equipment. Regular testing and maintenance are essential for maintaining the integrity of the oil and preventing costly failures. Always consult with qualified professionals for advice and guidance on transformer oil management. Their expertise can help you make informed decisions and ensure that your transformers operate safely and efficiently.